AI is a hot topic today. Everyone's trying to be the first person to theorize where it came from or to project where it would go in the future. And as an ambitious scholar, I'm trying to trust myself upon a similar task. Currently in the US, everyone's going for the movement called the recursive self-improvement, where the neural network can develop some sort of consciousness by identifying its own weakness in the algorithmic process. It's kind of like an early version of general intelligence. And here in China, we're actually taking a very different approach. We're getting very good at narrow task AI, which are a form of expert systems that perform division of labor in very specific tasks so they can excel in it. And really, the big question is, what should us researcher do or pick as a discourse as something that we trust upon ourselves? And in order to do so, we cannot do it without data. So I've decided to go through history in order to extrapolate that future. Trained as a designer, I've decided instead of taking a traditional research framework, I'll take a speculative design research approach, which what it really means is that taking from past data, you come to the present and you extrapolate possible futures as an outcome. So first, a little definition, what is the black box city? Well, in today's digital turn, urban development has itself become a black box because it become a complex system with internal workings that are opaque, but the input and output we can attempt to steer. And I argue that this is not merely a new set of tools, but it's actually a paradigm shift in the way that we design. Epistemologically, it asserts knowledge as digital traces. As a method, it privileges classification, prediction, and optimization. Its ontology navigates city spaces computationally, and its cases interface between built environment and its people. But to truly grasp the implication, we must look beyond that. And this is actually a diagram made by a friend of mine, Melinda Wagner. And we can see that the history of AI goes back to 1950s. We've been through a lot. It was the post-war period. Everyone wanted to democratize military technology to domestic settings. We've experienced 2 AI winter because of the oil crisis. And then we see a Cambrian explosion of big data that came with the explosion of the internet. And so that brings us to where we are today. And I intend to dissect this history of intelligence through the connectionism, symbolism, and actionism framework. And at the end of it, I'll propose a research framework that will be used to engage different stakeholders in the next step. And the key question is, what kind of minds are we building for the future city? Now, of course, everyone knows the most popular paradigm now is the neural network, is an intelligence characterized by bottom-up and emergent. So we actually discover interpretation of vast amounts of data and patterns in it. It learns by finding patterns. And so through this lens, we must think about how the city is first and foremost a statistical pattern to be interpreted, much like in a past presentation, which was a very good example. It's an accumulation of individual decision, movement, and interactions. And so we would see that in convolutional neural network, where straight images are used in machine vision, like in the last project. We see unsupervised learning. Yeah, I'm actually a lecturer at Bartlett, and this is what we do a lot at RC14, where we extract points of interest from urban data. Supervised learning prediction model trains, again, on historical data to forecast future states. But then all of these movements have a big problem, is that if we directly apply them to urban design, we have a digital determinism, where actually decisions are made of opaque models that internal logics and inherent biases we don't fully comprehend. In a symbolic movement, it's actually the oldest and most classical AI paradigm, is rigorously top-down and rational. Intelligence is achieved by manipulating explicit symbols, including rules, codes, and logic statements. So this is from the father of AI, Marvin Minsky. His original conception is that you can have a legible text authored by rules. So in urban design, you can essentially have regulation, building code, zoning law being encoded as an architectural grammar. And the mathematical rules can then configure spatial topology. So then city is generative. Space syntax, as mentioned before, profoundly symbolic theory. It tries to encode urban life as a set of graph, and with machine learning, it can benefit the acceleration of neural network clustering. Generative design, like parametric system, now at times also very familiar, we use perimeters encoded with sunlight, wind, and zoning, and with neural network, we can nowadays project more into microclimates and individual feeling of surrounding environments. And building information modeling, ultimate symbolic universe, because every door, window, wall, duct is a data object governed by rules labeled with semantic data, a functional relationship. Again, there's always downside. It risks being a sterile over rationalized city, a code of the code that we're essentially programming together, but no one has the actual overall picture. And the final movement we see, it's also a big hit now with the NVIDIA last Expo. They basically announced that they're going to do embodied AI. And what they're trying to do is that they do a potential synthesis where intelligence is not just processing information, but actually learning through action between an agent and its environment. So it's learning by doing, more like a human approach. In urban epistemology, this makes city as an interface for artificial intelligence to learn within an environment. So the city can either be a simulated environment or a real physical environment. For instance, reinforcement learning, the AI agent was being put in a simulated space and it takes action much like an autonomous car. It's a low-cost way of training it. Digital twin, again, live, dynamic, interactive virtual replicas where human action are real-time fed into a system that then simulates itself. But we also have an interesting movement of participatory AI, where public engagement are in the actual AI development, so it performs human in the loop as a collaborative experiential process for the AI to learn. Again, it also has a cons, because this synthetic pathway are grounded in intelligence of real-world environment. It's dynamic, and also the behaviors can be unpredicted and unsafe, much like imagine if you're in an autonomous vehicle making its own decision and is making unpredictable behaviors. And so I intend to show that as designers, these ideas have been embedded in our approaches to design as early as the 60s and 70s. And through the generative project of Cedric Price, I will then propose a design mechanism to renovate that in today's time. So a little introduction about this Cedric Price project. It tries to make a thinking facility in Florida with 150 movable blocks and one crane, so kind of like in a robotic arm. Configuration of the blocks can be done by its user through a central computer that harvests patterns in the user behavior. And the computer was essentially a primitive connectionist core engine because the purpose was to observe and learn from digital traces to find patterns and then make decisions. So then all of the behaviors are articulated into a series of variables that can be computed. So it's also a symbolic way of doing it. And he also imagined a future where the city is a machine, automated to cognitive behavior. The crane, aka the robotic arm, will then be able to build the physical environment through a feedback loop. And of course, he also demonstrated through physical prototyping and 1.1. So it's also an actionist activation because the data then gets feedback into the learning system. And so what we can learn from this is that mathematical, human, and physical properties are then integrated through connectionist, symbolist, and actionism approach to spatial intelligence. Which is why in the last phase, I intend to use speculative design to propose an architectural system that we can actually implement in a real-world context. And we're working with stakeholders in it. The Northern Metropolis, Hong Kong, 2050 will be one of the key development areas. As you can see right now, it's composed of, that's Shenzhen, very developed. And then Hong Kong has its back to it. So we only have wetland, abandoned farmland, and also brownfield sites facing Shenzhen, which is not very ideal. What we wanted to do really is to have a synthesis rather than someone having a big marker drawing a straight line in the area. And Hong Kong actually has culture. We do have indigenous Hong Kong Canton style Lingnan culture in the villages. They're understudy right now. We also have nature, as you can see, heavily polluted by the brownfield sites. And we also have the machine that we have to design spaces for them. So how can we have a system? Well, I propose a three-step approach. First, we need an ecosystem translator. Using the connectionist core, of course, we can have neural network to train on real-time sensory data in terms of migratory birds, water salinity, human movement to find nonlinear correlations. But what do we do with the correlation is the key question. And so we actually need the sensory data with knowledge graph of vernacular roots to transform ecological data with vernacular knowledge into living maps. And in the second step, we need the cultural generator to actually embed symbolic scenario into these roots. So we actually need a kit apart, which is a digital library of systems that can encode cultural folklore, traditional patterns, and symbolic sound, because we don't want to colonize ourselves with Eurocentric design and algorithmic biases, and to integrate that with ecological symbols. And then in Hong Kong, we have a very special system called a gateway, which is essentially can retrace back to the Song Dynasty, where we use a water gate to help catch fishes on the wetland area. And so we can use that to embed graphical rules of how the graph actually map onto a geographical zones. Then we can have symbols that we can tag on that map. And finally, with the actionist activation, we need to engage local community and residents actually living in the area to help validate human in the loop, like whether or not the neural network outcomes are actually qualitatively also standing to match current context. And this should manifest in a simulated environment. You can imagine it more like a video game with agents in a system, but then the data are actually contextualized through community input. So that's the overall framework, that the connectionist actually relies on a symbolic kit of parts, and the symbolist is ultimately the actionist event to validate, and the actionist, again, uses the symbolic universe of pre-programmed code. And in that way, although we're all looking at individual narrow tasks, you find a system to actually capture them as a more interactive intelligence. So to quickly summarize, what does it mean to build a mind for the future city where we can put together human culture, non-human ecology, and machine intelligence? Well, without just focusing on AGI as an agent that knows everything, or a narrow task AI where many agent only knows one thing, I think we're heading towards a synthesis of the spatial intelligence. And that actually goes back to the original proposal in the steps towards artificial intelligence as proposed by Minsky, where you need a frame to actually encapsulate different expert systems. And it also aligns with the idea that urban knowledge is both bottom-up and top-down, because the computer was a proto black box to find correlation, but the human operator actually uses theoretical guidelines to actually encapsulate the patterns. And this became what Douglas Hofstadter referred to as a self-referential system performing a recursive improvement function. So in the next step, we're engaging residents in Northern Metropolis, and NGO working in the region, planners in Technopole, ecological scientists, and architects and designers in January in Hong Kong to actually have a workshop and a symposium that will actually refine the framework into a rigid system proposal to be implemented as a blueprint for the next stage. And we welcome everyone to work with us and collaborate and get your expert input. So welcome to get in touch with me if you're interested. And if you have any question or critique, it would also be very helpful for us in the next stage.